Well, ever since humans discovered fire, we have a tendency to make things hot. But not everything's accepted that way. And so we definitely need to find things that can withstand being hot. Temperature, in layman's term, is the measure of how hot or cold anything is, which depends on the kinetic energy of the particles in the said material. This can be thought of as particles in fluid. Liquids and gases are fluids. Their particles are not fixed in place, they move around the bulk of the sample of matter. The model used for explaining heat transfer through the bulk of liquids and gases involves something called as convection, which is the process of heat transfer from one location to the next by the movement of fluid. The moving fluid carries energy with it, and the fluid flows from a high potential to a low potential always. It's not the temperature of the material, but the way materials carry it around that decides the efficiency of the material, whether it's good or a bad conductor of heat. The heat transfer continues until the two objects have reached thermal equilibrium and are at the same temperature. Heat can move from one point to another in three basic ways we know of: by conduction, by radiation, or by convection. It also does not depend on the element, but the way the atoms of that particular materials are structured. Wood, as we all know, is a bad conductor of heat, whereas diamond, made up of the very same carbon atoms, is an excellent conductor.
So when we put water to boil, its molecules vibrate with greater and greater speeds as it heats up. Similarly, if a sample of water is placed in the freezer, its molecules begin to slow down. Now, wait a minute, this kind of feels against the second law of thermodynamics. The second law of thermodynamics, which states that the total entropy of an isolated system should always increase. We need to keep this in mind. It's not the entropy of an individual system we are talking about, it's the entropy of the universe as a whole. The energy it takes a refrigerator to make ice increases entropy more than the freezing of water reduces it. The giving end can be called a source, and the receiving end a sink. Our world is full of sources and sinks, and unless we can get 100% efficiency from the system, which is kind of impossible to do, there will always be some kind of heat generated. Heat dissipation occurs when a hotter body is placed in a colder environment where the heat is transferred to its surroundings equally in all directions. That's the reason why we cannot feel the heat from a hot cup of tea while sitting on the other side of the room.
Now we're going to do a small demonstration of thermal conductivity. Here I have two types of cups, which are stainless steel and ceramic. We're going to fill tea in these cups and measure the temperature at finite time interval. To measure temperature, we're going to use most feared weapon of the lockdown, the infrared thermometer. Zeroth Law of Thermodynamics states that when two objects are placed in contact, heat or energy is transferred from one body to other until they reach the same temperature. We call it thermal equilibrium. When the objects are at the same temperature, there will be no heat transfer. So we will stop taking data when the temperature will be same as room temperature. We make a plot of temperature versus time. By plotting temperature versus time graph for both the material, it is clear that due to the high thermal conductivity of the steel, the heat from the tea is rapidly transferred to the cup and then to the surrounding. Although, based on knowledge surrounding heat capacity, the ceramic mug is better than stainless steel. Heat capacity is the ability of material to hold heat per unit volume. Due to the lower density of ceramic and thanks to small pores in the material, heat can be stored within the mug itself rather than being released into the surrounding area. While the heat stays within the mug barrier, the equilibrium reaction is being maintained between the mug and the tea, preventing the tea from cooling off too quickly. The next time you are out shopping for your new favorite mug, remember how thermal conductivity and heat capacity can affect the warmth of your drink.
Consider this case where our sun emits electromagnetic radiation all around, and we receive a very small percentage of that radiation emitted. Now that energy is stored by the plants in the form of wood or fruit. We consume them as fuel. Basically it is converting heat into mechanical energy. Well, a simple thing, but it's still beautiful. The simple process gives rise to complex life forms. Without heat transfer, there won't be neither life nor